Okay, we're going on now to topic 1.3, equivalent algebraic expressions. Now in this section, we'll look over the commutative, associative, and distributive laws that operate in arithmetic, as of course algebra. We'll do combining like terms and checking by evaluating. Now, what are equivalent expressions? Well, they are expressions that have the same value. So what would be on one side is equal to what is on the other side. And we'll see some examples here. So for instance, in our first law that we're going to discuss is the commutative law. For any two numbers, A and B, the order in which we add them doesn't make any difference, and in a sense give us equivalent expressions. So A plus B equals B plus A. That is the commutative law for addition. And the same applies for multiplication. If you have A times B, then that's equivalent to B times A. So far, not too difficult. And a second law that we're going to look at is called the Associative Law. Here, if we have numbers A, B, and C, in the Associative Law of addition, we can add the B and C first. And we could also add the A and B first. That's what's illustrated here. So you associate by putting parentheses in different positions. And that's allowed, it's true. The same thing applies for multiplication. Here you can multiply B times C first, and then multiply it by A, or multiply A times B, and then multiply it by C. So now they want us to write equivalent expressions to show the commutative law of this. So basically what we're going to do is switch the order around and say 7 plus 3x. Now, normally you don't see this one where they put the x in front of the 3. It's okay, but the rule is you usually put the number first and then the variable. So these are all possibilities. Now, how about writing something using the associative law? Well, notice here's an order, but we're adding these two items first. And I'm assuming in the next slide they're going to change the parenthesis to be here and here, where we would add the y and the 1 first. Exactly. Now, we also have another law that's quite common, and we'll be using it in Chapter 5 quite a bit. This is called the Distributive Law. For any real number A, B, and C, we're going to take the A and multiply it by the B and get this. And we're going to take the A and multiply it by the C and get this. Now, notice you now have two terms, but there is a common A factor in each one that we distributed here. So shortly we're going to see the reverse of this, where it will say to factor out a common factor. When we do that, we'll take the A out and it will look like this. So these two often go hand in hand. Here the A is now by itself, and we'll be using that technique in a later lesson. So write an expression equivalent using the distributive law. So we're going to take the 5 times the x and get 5x, 5 times 11 and get 55. And in the slide, they show you the steps, and then you get your results. So note there is a common 5 factor in both of these that if we factored this, would go back to this. And here they want us to do that. So what is the common factor? Think about it for a moment. And it's going to be 8. You could factor an 8 out of this and an 8 out of that. And when you do so, there is your 8, and there's your x, and a negative 3. So if you distributed, you would get back where you started. Okay, this is another very, very important part. And here what we want to do is to combine like terms. What is a like term? Well, a like term is any algebraic or expression in which the variable part is exactly the same. And notice as you look at these terms, the first thing they want you to do is identify first what a term is. So I had jumped ahead a little bit with like terms. A term, as we mentioned, and I believe in our first video, was those separated by a plus or a minus. So in this case, this is one term here, this is one term here, and this is one term here. So this expression has 3 terms. Now we're getting to this part. When the terms have exactly the same variable, we consider them to be like or similar terms. So for instance, in this example down here, the variable is x to the 8th, and here the variable is x to the 8th. So these are like terms. Now, what they want us to do here is to combine like terms. So let's see first if we can identify the like terms. Well, here is m to the 2nd. There is an m to the 2nd. So these are like terms. And we have a 2 and a negative 5. That will leave us with a negative 3m squared. And I'll even change color. Now here we have m. Remember, that's to the 1st. If there's no exponent, there's a 1 there. And then this is m to the 1st. And if there's no constant in front of a letter, we assume there is a 1 there. So here we have a 3m and a 1m. That will give us a plus 4m. And then we have what's left. Well, we also have, by the way, we probably should have done this one first. This one doesn't have any other like term with it, and we always like to put them depending on their exponents. So I'm going to change color and put that If I can get to the spot here. Here we go. 4m to the third right there. And then what are we left with? Well, we're left with a plus 2 and a plus 11, which will give us a plus 13. So now we see there are no more like terms to be combined, so we have done that successfully. Now later I'm going to show you another technique for doing this that may be helpful, but we're going along with what they're showing us right now. And what they did is they put all the like terms together, in a sense using the commutative and associative principle, and eventually they got what we had. Notice they didn't put the 4m to the third up in front. But again, this is okay. Ideally, you want to put the higher exponents out toward the end, but we're going to be doing something with that later. So here, as we look at it, there's an A and there's an A. So these are like terms. So a 3a and a negative 8a, that's going to give us a negative 5a. And here we have a negative 4b and a 10b. That will give us a positive 6b. If you're thinking that, that's good. And again, you can check your work. So there we have it. Now, here they're asking us to use a calculator to evaluate this. We're just going to do it regularly, and we're going to do some substitution. Here we have 3, and then we said x is 4, minus 2. And if x is a 4, this is going to be 12 minus 2. This will equal 10. And then if x is a negative 3, we go 3 times a negative 3 minus 2. This will give us a negative 9, and a negative 2 gives us a negative 11. We don't require a calculator for the course, but the use of one is acceptable. And that completes this section.